5, 4, 3, 2, 1. And liftoff of NOAA's GOES-R, America's most advanced weather eye in the sky, elevating environmental intelligence to new heights and saving lives.
I'm Dr. Frank Aparvier. I'm a senior research scientist at the University of Colorado at Boulder's Laboratory for Atmospheric and Space Physics. I'm the science lead for the GOES-R EXIS program here at LASP. So GOES stands for Geostationary Operational Environmental Satellites. It's a program sponsored by NOAA, the National Oceanic and Atmospheric Administration, in particular the National Weather Service. And it's a satellite system that's been operating since the 1970s. They keep launching new ones. And the GOES satellites provide the nation with all of the satellite weather imagery and data. Every time you watch the weather on the news or you go online and look at forecasts and look at satellite imagery, that all comes from GOES. And the GOES program is considered a national asset, and the measurements it makes are so important that they actually fly 3 satellites at all times. They're geostationary satellites, which means they're orbiting the Earth at the same time that the Earth rotates, so that the satellite is basically sitting over one spot over the Earth. And we have one over the East Coast and one over the West Coast, so we have good coverage over the whole Western Hemisphere. GOES has a host of instruments that monitor the space weather around the Earth. Space weather is driven by variability on the sun and impacts the upper atmosphere of the Earth and the magnetosphere, the magnetic field, and it changes the energy and particle environment where satellites fly and through which satellites communicate and cell phones communicate and things like that. So a storm on the sun, a solar flare, can go off, and within minutes the light from that reaches the Earth and will ionize the upper atmosphere. It can affect satellites, it can damage circuitry, it can damage astronauts. EXIS stands for the Extreme Ultraviolet and X-ray Irradiance Sensors. It's an instrument that measures the light from the sun. It's measuring the total amount of energy as a function of wavelength coming from the sun and impinging on the Earth.
Hi, I'm Dr. Tom Woods with the University of Colorado. I'm the Associate Director for the Laboratory for Atmospheric and Space Physics, LASP. We're a lab at the university that builds a lot of satellite instruments for NASA and NOAA. For the NOAA GOES-R series, we have the EXIS instrument, which stands for EUV and X-ray Irradiance Sensors. It has 2 primary instruments. It has the EUV, which stands for Extreme Ultraviolet Sensor. It measures the short wavelengths to measure solar flare activities. It's this larger instrument here with some gratings inside. It also has mechanisms on the front to help select different wavelengths and different filters. And then we have a smaller instrument here called XRS, which stands for X-ray Sensor. It measures in the shorter wavelengths the X-rays. The main purpose of EXIS is to study the solar storms and how it affects space weather here on Earth. Both effects in the atmosphere as well as effects on the satellites and our technology in space.
Space weather in general impacts human activity both on Earth and in space quite a bit. Variability on the sun causes variability in our upper atmosphere, in the electrical circuit of our upper atmosphere, and the temperature and composition of the upper atmosphere and the densities. And so direct impacts of solar variability are things like when a flare goes off on the sun, it changes the amount of ionization in the upper atmosphere, and that changes how radio waves are propagated through from ground to satellite or even from ground to ground, because we use the ionosphere to bounce radio waves off to get around the curve of the Earth. Communications disruption can occur when solar activity occurs. One primary impact that people have these days is everybody has GPS, Global Positioning System. GPS works that you have a receiver either in your watch, on your phone, or in your car, or these little handheld devices that is receiving signals from satellites that are orbiting the Earth. And it uses those signals to triangulate your location to within a few centimeters or less. And solar activity will change the upper atmosphere and how it transmits those radio waves. It basically acts like a lens and changes the direction of the radio waves. They get refracted. The Earth is like a magnet, a bar magnet with the north and south, and energetic particles will follow those field lines and come into the north or south pole of the Earth. And the obvious impact is the northern lights. We see increased northern and southern lights, the aurora, but that also is a lot of extra heating and a lot of extra electricity going into the atmosphere that has a global impact. That can really disrupt GPS and communications. One of the impacts of space weather is it changes the circuitry in the upper atmosphere and in the ground. It's all one big connected electrical circuit, and we have covered the Earth with wires. And those wires are carrying not just signals of television and communications, but also power. We've connected all of the power grids in the Earth to each other, and we buy and sell and move electricity all over the place. And if you change the currents in the ground, that changes the currents in those wires. Basically, we have this big antenna that can pick up any changes in the electric circuit of the atmosphere. And so if you get a lot of electricity flowing in the atmosphere, it can cause more electricity to be flowing in the wires, and that can cause overload of circuits. It can cause blackouts. In the 1980s, there was a big blackout in Canada that affected the east coast of the United States that was caused by a coronal mass ejection from a big flare that came to the Earth. And if they had had all of these instruments, they would have known it was coming, but they didn't at the time. And it caused a blackout. It burned out a transformer. If we had one of the biggest storms that we've seen in the past happen now, the impact could be in trillions of dollars, and due to power outages and loss of communications and how long it would take to recover from that. Many things we do every day are affected by and controlled by satellites. We have satellites that are monitoring the weather. We have satellites that are transmitting our television. We have satellites that are transmitting the internet. All of that is using radio communications from ground to space and back down to ground again. And if you disrupt that by adding a lot of extra static to it or disrupting the satellites themselves because they're being bathed in radiation and don't work as well, all of that has an impact on our everyday life.
Combining the GOES operational measurements, the NASA research measurements, we can better understand the space weather effects on Earth, learn from that, and then take those lessons learned and apply them operational for NOAA for actually making real-time forecasts, minute-by-minute type forecasts for the effects that are expected here on Earth.
The data flow from the GOES instruments is very quick. The data is taken on the satellites, and because they're geostationary, they're sitting over a particular spot on the Earth, and there are dedicated satellite dishes that are looking at the satellite and receiving the data from them continuously. Many places around the United States have receivers, and if companies like the power companies need that data immediately, they will buy their own receiver and look at that data. So they have it within seconds. The space weather data comes here to Boulder to the NOAA Space Weather Prediction Center, which then they turn around and make available to the public via the internet, and those higher level data products are tailored to this is the impact at the Earth from this, or this is the forecast of what's going to happen in the next few hours or days because of something that happened on the sun. And that's all available through the NOAA Space Weather Prediction Center website. They have live streaming of their data and archives of past data for people to use.